All right, let's get started, guys. Today is Wednesday, October 21st. It's an A day. I've got a warm up here for you. So if you're watching this and you were absent, please make up the warm up to get credit for today. I'm going to give you guys a link. I'm going to put the link in the Canvas page. So if you go to our main homepage and look at day 4 for Wednesday the 21st or Thursday the 22nd, both of these days is day 4. If you need to make up day 4, please complete the warm up that is listed there. Okay. Basically, you're going to describe what a picture of the atom should look like. So if you close your eyes and picture an atom, what do you see? What does it look like? Try to describe it. And then what parts should we include in our model of the atom? If we were to build an atom, what um, what should we put in it? All right, and then where can we look to determine information about atoms or elements? Okay, and we'll talk about this in class. So this is the agenda for today, day 4. We're starting Unit 3 on atomic structure. We've got a warm-up, we've got a video lesson and an ed puzzle, and this should be around 30 minutes. And then we've got an in-class activity and an exit ticket. So lots of in-class stuff, okay? We've got to be participating. Students are expected to complete the warm-up activity during class. Students are expected to complete the video lesson ed puzzle by the end of the day. Participate in the in-class activities and exit ticket during class, okay? Now, if you do the exit ticket after class, that's fine, but you should be participating in all of our in-class stuff in order to get credit. If you're not participating during this stuff, then you will be losing lots of points. Okay. Learning objectives. Students will be able to identify the masses, charges, and locations of the major parts of the atom: protons, neutrons, and electrons. So we want to be able to identify the mass, the charge, and the location of the proton, the mass, the charge, and the location of the neutron, and electrons. Same thing. Identify the atomic number and mass number of the elements. So here's an element. What is its mass number? What is its atomic number? Determine the number of protons, neutrons, and electrons in an atom. Okay, so pretty easy learning objectives. And some of this stuff you guys probably know. So students are expected to complete the ed puzzle during today, not necessarily during class, and I'll put the links here. So students are expected to complete the ed puzzle by the end of the day, virtual or face-to-face, and then students are expected to complete in-class activities. All right, so we're going to do stuff on the whiteboard. All right, here is an overview of Unit 3 on atomic structure. We'll spend some time talking about basic atomic structure, what is in the atom. We'll talk about isotopes. We're going to do an activity where we will build, it's called Building an Atom, and it's a PhET virtual lab simulation, which is kind of cool. So hopefully that'll be kind of fun. We'll talk about the history of the atom. We'll talk about average atomic mass. We'll talk about arrangements of electrons around the atom, and then we'll talk about nuclear chemistry a little bit. So this is a really cool chapter, really cool unit. Here's a picture of the atom. Maybe this is kind of what you were thinking in your head about what an atom should look like. This is actually an older model of the atom. This is the Niels Bohr model of the atom, made in the early 20th century. This is actually kind of old because this is about, don't quote me on this, but I'm thinking 1910 is when this model of the atom came out, and that's 100 years ago. So this is a pretty old model of the atom, but if you close your eyes and think about what an atom looks like, this might be kind of similar to what comes to mind. But this is where electrons are in fixed orbits around the atom. We call them energy levels. And so this is Niels Bohr, his interpretation of what the atom should look like. All right, so I've got 3 slides here and a lot of stuff on each slide. So if you take the atom and look inside of it, what is in there? There are things called subatomic particles. All right. Most of the atom is right here. This is the nucleus. Okay, and then we've got these electron shells. shells of electrons orbiting the atom. And we're just showing this as kind of like a planetary model of the atom, where this might be the sun and these are the planets and their respective orbits. And this is kind of still the Niels Bohr model of the atom, and we'll talk about different models later. But the nucleus is at the center, and it's right here, and then we've got these electrons out. So let's talk about each of the subatomic particles. There's the electron, there's the proton, and the neutron. All right, so let's start with the proton. Proton is a positively charged particle. Okay. Proton starts with P, and so does positive. So it's positively positive. Okay, starts with P, positive proton. Say it, positive proton. Protons are located in the nucleus, or the center of the atom. They are right here. They're these positive things. They're kind of covered up, but those are protons. Okay. The proton is the same as the atomic number. Okay, and we'll talk about atomic number. So the number of protons is equal to the atomic number. The proton identifies the element. So the number of protons that an element has will determine what element it is. And it's important for mass. Okay. Positive protons, they're in the nucleus. They're equal to the atomic number. The atomic number is equal to the number of protons, and it identifies the element. It's important for mass. Okay, and that's because protons have mass. Everything in the nucleus has mass. Okay, what else is in the nucleus? There's protons and there's neutrons. So that is what is in the nucleus. Nucleus has protons and neutrons. So neutrons are neutral. They have no charge. They're also in the nucleus, and they also have mass. So they're very important for the mass of the atom. All right, so if you're counting up the mass of an atom, you better be counting neutrons. Okay, and if the mass changes, then we are changing isotopes, and we'll talk about isotopes later. So if you change the number of neutrons, if you change the mass of an atom, then you have different versions of the element that we call isotopes. Okay, so protons and neutrons are in the nucleus of the atom. So here's our nucleus, protons and neutrons, positive and no charge. There's a whole bunch of them in there, depending on what atom we're talking about. And then surrounding that atom are shells upon shells of electrons. And these electrons are zipping around this nucleus. Electrons are negatively charged. All right, so remember positive proton, and just remember electrons are opposite. They are negative. They are not in the nucleus, but they spin around and orbit the nucleus from a great distance away. They are considered to have no mass, so they do not affect the mass of the atom. They're not involved in isotopes, and they create a charge if equal to the number of protons. So if the number of electrons is equal to the number of protons, if protons is equal to electrons, then it has the same positive and negative charge, and they cancel out. So most atoms are neutral. Most atoms have no charge, and the number of protons is equal to the number of electrons. Okay, I want to introduce a couple of words here. If we're looking at protons, if we're up here in the green, if we're looking at protons, the number of protons tells us what element it is. Okay, if an atom has one proton, we call it hydrogen, because hydrogen's atomic number is 1 on the periodic table. If it has 2, then it's helium, and so on. So the element is defined by the number of protons. So the number of protons is very important. The number of protons also impacts the charge of the atom because they have a positive charge. All right, neutrons have no charge. They're located in the nucleus. They are very important for mass. So they affect the mass number. And if you change the number of neutrons in an atom, then we're talking about isotopes. So that's a very important word that we need to associate with neutrons. If you change the number of neutrons, you change the mass and you change isotopes. Okay, now electrons, if electrons change, then we have a charged atom, which is called an ion. Okay, ions are atoms with a charge. So So if you lose electrons or gain electrons, you now have an unbalanced charge. They're not equal. And so now it's called an ion. So an atom can become ionized if it gains or loses electrons. Okay. So here's 3 terms here that we'll be talking about more. Okay, let's continue. All right, what is in the nucleus? Here's our nucleus. What is in there? Protons and neutrons. The nucleus is the center of the atom. It contains protons, which are positively charged, and neutrons, which have no charge. The overall charge of the nucleus is positive because protons are positive, neutrons have no charge. So the only charge in the nucleus is positive. But that positive charge in the nucleus is balanced by the electrons that are orbiting, and so that the overall atom has no charge. Most atoms have no charge. Okay, and actually that opposite charge attracts, opposites attract, kind of like in real life. I don't know if you've heard that saying, but opposites attract. And so the same is true with subatomic particles. Protons attract electrons, and that's actually what keeps the atom held together. Okay. The nucleus is responsible for its mass. So all of the mass is in this nucleus. All of it. All of the mass of the atom is stuck in that tiny, dense nucleus. But the nucleus is very small compared to its volume, and we talked about that in class at the warm-up. All right. If you add up the number of protons and neutrons, then you get the mass. Okay. Now let's look at these electron shells. The electron shells surround the nucleus. They contain electrons, which are negatively charged. They are large in volume. They take up a lot of space compared to the nucleus. And again, we talked about this in class. The electron orbit is huge compared to the nucleus, but the electrons have no mass. So the electron shells have all the volume, all the space, but no mass. Okay. So here's a couple more terms here. I'm going to start with mass number. The mass number is the mass of an atom. So if I were to pick up an atom and describe it, one way that I could describe it is with its mass number. How much does it weigh? Okay. How do we get the mass number for an atom? We add up its number of protons and neutrons. That will give us our mass. Okay. Mass number is always a whole number. And when we look at this notation, if we were to describe an atom, we could use this symbol X. This would be the element symbol. For example, if I were talking about hydrogen, the symbol for hydrogen is H. And so I would use H to start this. The mass number would go up in the top right corner, top left corner. Okay. And the mass of hydrogen, let's say I had a hydrogen atom in my hand. It had 1 proton in the nucleus, and then it had 1 electron orbiting. So that's real simple. 2 particles, 1 proton in the nucleus, 1 electron zipping around this atom. That would be hydrogen. The mass would be just 1 because it's got 1 proton. So the mass would be 1, and it goes up in the top left corner. Now, let's look at atomic number. Atomic number is the number of protons. It tells us what element it is. It identifies the element. So hydrogen is an atom that has 1 proton. That's why we call it hydrogen. Helium is element 2. That means that any atom with 2 protons is helium. Okay? The atomic number is located in the bottom left of the nuclear notation. So this is the atomic number here. And so the atomic number of hydrogen would be 1, and so we would put a 1 there. Okay? So let's label this atomic number, or the number of protons, mass number, which is protons plus neutrons. Protons plus neutrons. Okay, protons plus neutrons. If we had a charge, it would go up in this corner. So if we had a charge, it would go here, but usually there's nothing there because usually we don't have a charge. All right, now if you look on the periodic table, you'll see elements that have this kind of setup. The atomic number is on top. That's the number of protons. Iron has 26 protons. Here's the symbol for the element. And notice that this is the name for the element, iron. And it's not, like, it doesn't really fit Fe. So you might be wondering why that is. Iron does not fit the symbol Fe because Fe is short for the Latin word for iron, which is ferrous, which starts with Fe. And so that's why sometimes they don't match. And I know that makes this tricky, but some of the elements we either need to memorize or just look on the periodic table and you'll see what the element symbol is. You just got to find it on there. So if you look at number 26, iron has a symbol Fe. And then down here is the average atomic mass. This is the average of all iron atoms in the universe. Okay? So the average atomic mass is below the symbol. The atomic number is above the symbol. Okay? And the periodic table is organized by atomic number. So if you look on the periodic table, it'll look like this. Right? If you look on the periodic table, there's one right there. That's 1. And then here's 2. And then 3, 4, 5. And then 5 through 8. And then 9 and 10. And then 11 through something. And it just keeps going. So the 19's down here. And then 20. All the way until we're done with. So it's organized by the atomic number, the number of protons. And that's because that tells us what element it is. So that's the most important number. The average atomic mass is on the bottom, and it tells us the average mass of all atoms of that element. So the average of all iron is 55.847. If we round this to a whole number, look at this 8. Since that 8 is above 5, we would round up. So that makes it 56. So if we round this number to a whole number, that is the most common version of iron. That's the most common. So if I pick up iron and I looked at it, how many, what's the mass of that iron atom? Most of the time it's going to be 56. And so that's the most common isotope. Okay. 56, so here we go here. Okay. So here's our periodic table again. This is kind of like what you would see on the periodic table that I'm going to show you guys. We've got the symbol for the element. We've got the name. Now, the name of the element is usually below the symbol. It's usually right here. Below the element. Okay, so mercury is usually going to be right there. And then we have the atomic number, 80. So the atomic number for mercury is 80. Remember, that's the number of protons. And that means that if you were to pick up an atom of mercury, it would have 80 protons in it. All right, and then this is the symbol here, Hg. Again, Hg is short for the Latin word for mercury, which is not mercury, but it starts with Ag and then something. And I can't remember what that one is. But the symbol is Hg. And the average atomic mass is 200.59. So the most common isotope would be 201, if you round that to a whole number. So if you picked up an atom of mercury, the number of protons from the periodic table would be 80, because its atomic number is 80. Okay. Its average mass is 201, and that's because we would round this to 201. So the mass number would be 201. Remember that the mass number is protons plus neutrons. So how could we determine how many neutrons this has? Number of neutrons. Well, we know the mass number, and we know it's 201, and we know the number of protons is 80. So how can we get number of neutrons? We could subtract them. If I take the mass number minus the atomic number, so if I take 201 minus 80, that'll tell me how many neutrons I've got. And I'm not going to do that, but that'll tell us how many neutrons there are in an atom of mercury, or most atoms of mercury. Okay, the atomic number represents the number of protons. Let me clean this off so I can clean it up. Neutral element will always have the same number of protons and electrons. So if you think about the charge of the atom, protons and electrons cancel each other out. Think about a tug of war. Protons are here and they're pulling, and then electrons are here and they're pulling. If there's more protons, then the protons win, and the atom will have a positive charge. If electrons win, they will pull it that way, and they will have a negative charge. Okay? So you need to find the difference between the two. Okay, the difference between the number of protons and the number of electrons will be equal to the charge. It'll be positive if you have more protons. It'll be negative if you have more electrons. All right, the mass of the atom is the number of protons and neutrons. So add up protons and neutrons and you get the mass. Okay, the atomic number is specific for each element. It's the same for all atoms of an element. So if I have a hydrogen atom, any hydrogen atom in the universe, it's going to have the same atomic number. It's going to have 1 proton, atomic number 1. That's why it's the first element on the periodic table, because it has atomic number 1. The atomic number is equal to the number of protons and electrons in a neutral atom. Most atoms are neutral, so they have no charge. So helium, for example, has 2 protons and 2 electrons. So what do you get when you take a positive 2 minus a negative 2? Or, sorry, take a positive 2 minus 2. You get 0. You get no charge. So atoms have no charge. Protons and electrons cancel out, so nobody wins the tug of war. So if nobody wins the tug of war, then you have no charge. And that's the case for most atoms. Most of the atoms around you have no charge. Okay? And then I've got some other examples that we'll do in class together. So I'll skip these. Mass number is the mass of the nucleus. It's protons plus neutrons. The proton has a mass of about 1. The neutron has a mass of about 1. And then electrons have no mass, so we do not count their mass. So here's a table with the details for each particle. Protons have this symbol. Here's their charge. Here's their mass in grams, which is really tiny. That's not really important for us, but that's the mass of a proton. Here's the mass that we're going to use. We're going to use just 1, right? The mass of a proton is just 1. The mass of a neutron is 1. And then the mass of an electron is 0. Protons and neutrons are in the nucleus, and then electrons orbit the nucleus. Electrons have a negative charge, and they have that symbol. And here's their mass as well. The mass number is equal to the number of protons plus the number of neutrons. Okay. And I think I got one more slide. Okay, so here's our chemical configurations. Let's look at this. So this is carbon-12. That's where we write the name of the element. So the name or even the symbol of the element, name or symbol, and then a dash. It's not a minus sign, it's a dash, and then 12. And that is the mass number. So that's the total mass of a carbon atom. And so the mass number goes here. The atomic number goes here. So 12 is the number of protons plus neutrons. So 12 equals protons plus neutrons. This is the atomic number, 6. And so 6 is equal to the number of protons. So how can we get number of neutrons? Neutrons is equal to the mass number minus the number of protons, which is 12, this one, minus this one. So 12 minus 6, we get 6. So this is an atom of carbon. It has 6 protons. It has 6 neutrons. A total mass of 12. And so there's 2 ways to represent this atom. One of them is like this, and one of them is like this, and they mean the same thing. This one doesn't say 6, and it doesn't have to because it says carbon. If you look on the periodic table, carbon is element number 6. So we don't really need that part. All right, here's an atom of chlorine. It has an atomic number of 17. That means it's equal to 17 protons. And then this is the mass number, which is, again, it's the protons plus the neutrons. So how could we get the number of neutrons for chlorine? We can take the mass number minus the atomic number. So we could take 35 minus 17. That'll give us our number of neutrons in this particular atom of chlorine. All chlorine has 17 protons, okay? But the mass can change. All right, here's another version of carbon, carbon-14. Remember that 14 is the mass number. Just like this is the mass number here. That's number of protons plus neutrons. And then this is just protons. This is the atomic number of protons. So the number of neutrons for this isotope of carbon, this version of carbon, would be mass number minus atomic number, 14 minus 6, which would give us 8. So this is a version of carbon with 8 neutrons. Over here, we had 6. So both of them are carbon because they have 6 protons. Any atom with 6 protons is going to be carbon, because that's the way it's set up on the periodic table. And then the mass would be 14. It would have 8 neutrons. Okay, and that's it, guys. Until next time.